everybody, today we're going to look at probabilities with counting methods. I'll include multiple calculators and the steps needed to find the solutions. A coffee shop has 14 employees, 8 men, 6 women. 4 are selected to open the store Saturday morning. Let's find the probability the 4 selected are women. Since we can't have repetition, we know we need to use a combination or a permutation. But when we select the people to open the store, who we pick first, second, third, or fourth doesn't matter. So because order doesn't matter, we know we're going to use a combination. We'll start by finding the number of ways to select 4 people in general. This will be our sample space. We have 14 employees and we're selecting 4. So we know our sample space is a combination of 14 choose 4. Next, we need to determine how many ways we can select 4 women. Because we had a total of 6 women and we're selecting 4, we're going to find the combination of 6 choose 4. The numerator will be the number of ways to select 4 women. The denominator will be the number of ways to select 4 employees. Now we're ready to use technology to find our solution. I'm going to start in Desmos. In Desmos, you can go to the functions and scroll down to find combinations. We want the combination of 6 choose 4, and then we're dividing by. You can also type in N, capital C and R. Desmos will recognize the function. Then you could continue to type 14, 4. Notice you have 2 options here. You can use the decimal, 0.014985, or it allows you to change back to a fraction, and you can see 15 over 1001. So pay attention to what you're asked for and the problem you're solving, but know that you can switch back and forth in Desmos in most cases. In this case, I'm going to look at the 0.014985 and I'm going to call it 0.015. That says we can change that 0.015 into 1.5%. This says if we're just randomly picking people to open the store, there's only a 1.5% chance that the 4 people we select would all be women. Next, a swimming race has 10 contestants. We want to find the probability of randomly guessing the first, second, and third place winners. Because order is important, we need to use permutations to find the result. We need to look at how many ways we can order 3 of 10 contestants. That forms our sample space. We'll calculate the permutation of 10 choose 3. For the numerator, there's only one way to guess the right order. You get it right. So our numerator in this case is just a 1. So we'll go back to the calculators and figure out 1 over the permutation of 10 choose 3. This time, let's try a few TI calculators. I'm going to start with the TI 30XS. I know I need to do 1, and then I'm going to hit divide by. I'm going to put a parenthesis to help me keep track of what we're doing. I need to look at 10, and then the permutation, I hit the PRB button. The first choice is permutation, so we hit enter, and then I put a 3. I'm going to close the parenthesis and push enter. It gives me 0.0013888888. So I'm going to think of that as 0.0014. Let's look at a second TI calculator. This one's the TI 30XA. When you look over the keys 8 and 9, you can see combinations and permutations. So I'm going to do 1 divided by. Again, I put a parenthesis. I know I need to start with 10. Then I hit the second and 9 to get a permutation, and then I put in 3. I close the parenthesis and I push enter. Again, I get the 0.0013888888. For a slight second there, when I pushed the parenthesis, we saw the number 720 appear on the screen. What that represented was the permutation of 10 choose 3. This could be helpful if you just want to do the numerator and then the denominator. So I would have 1 in the numerator, 720 in the denominator, and I could put my answer in as 1 over 720. How you put in the answer, again, all relates back to what's asked in the question that you're answering. So you might have to give percent, you might give decimals, and you might give fractions, so just pay attention to the wording. Let's try one more. A bakery sold 50 loaves of bread to a caterer for a luncheon. The bakery knows 8 of the loaves are burnt on the bottom. If the caterer selects 8 loaves to inspect at pickup time, we're going to first find the probability that all 8 are burnt loaves, and then we'll find the probability that all 8 are not burnt loaves. In this case, order doesn't matter, so we're going to use combinations. We're going to start with our sample space. There are 50 total loaves, and we're selecting 8. Then in part A, we want to find the probability that all 8 are burnt. So that means we need to know how many ways can I go from 8 loaves and choose all 8. This is what we need to put in the calculator. We need the combination of 8 choose 8 over the combination of 50 choose 8. Let's look at this in pieces. If I start with the combination of 8 choose 8, I get 1. That says when there's 8 items and I choose all of them, there's one way to do it. I pick all of them. I also want to know how many ways can I pick 8 of 50 items. That number is much larger. I have 536,878,650. Notice if I do this all at once in Desmos, it gives me this really small value, and it does give me the option to turn that back into a fraction. To keep things easy to read, I'm going to keep the answer in fraction form. Let's go on to part B, where we're supposed to look at the probability that all 8 are not burnt loaves. The first thing I think about is 8 are burnt, which means 42 are not. To find this probability, we need to find the combination of 42 choose 8, the number of ways to select 8 loaves from the 42 that are not burnt, and then divide by our sample space. Let's go back to the calculators. We'll start in the TI-30XS. I'm going to put a parenthesis, and then I'm going to put in 42, hit PRB, select combination, and then say 8. Let's close the parenthesis, divide by. Let's do another set of parentheses. I'll put in 50, then PRB, combination, and choose 8. This gives us 0.2198. Maybe I would round that up to 0.22, which is about 22%. Let's also try that in the TI-30XA. I'll once again start with the parenthesis. I put in 42, and then I hit second and the 8 to get a combination, and we're selecting 8. I close that parenthesis, and you can see the value for the numerator. Let's divide by, do another set of parentheses, go back to 50, hit second and 8 again to do my second combination, and we're selecting 8, close the parenthesis, I can see the denominator, push equals, here's my final answer. In both cases, we got the same solution, which was about 22%.